Hello and welcome. In today's tutorial, we're going to learn how to perform one-way ANOVA in RStudio, step by step. We'll cover what ANOVA is, how to load and check your data, test the assumptions, run the analysis, perform a post hoc test, visualize the results, and interpret everything in simple terms. Let's get started. Step 1. What is ANOVA? ANOVA stands for Analysis of Variance. We use it when we want to compare the means of three or more groups to see if they are significantly different. In ANOVA, we have a dependent variable, which is what we're measuring, this must be numerical. And an independent variable, which is the grouping factor, this must be categorical. In our case, we'll use a built-in dataset in R called plant growth. The dependent variable is plant weight, and the independent variable is treatment group, with three groups named control, treatment 1, and treatment 2. Step 2. Load and view the data. We start by loading the dataset and viewing the first few rows. This will show us the structure, one column for plant weight and another column for the treatment group. This step helps us understand what kind of data we are working with before jumping into the analysis. Step 3. Check assumptions. Before we run ANOVA, we need to check two key assumptions. First, we check whether the residuals, that is, the difference between observed and predicted values, are normally distributed. We do this using the Shapiro-Wilk test. If the p-value is greater than 0.05, the residuals are considered normally distributed. Let's say our result shows a p-value of 0.2. That means this assumption is met. Second, we test whether the variances are equal across the groups. We do this using Levine's test. If the p-value is greater than 0.05, the variances are equal. Let's say our result shows a p-value of 0.35. Again, this means the assumption is met. Step 4. Perform one-way ANOVA. To run the ANOVA, we use the AVE function in R. This will tell us whether there is a statistically significant difference in plant weight between the treatment groups. Let's say our ANOVA result gives us a p-value of 0.04. This is less than 0.05, so it means there is a statistically significant difference. In other words, at least one of the treatment groups has a different mean weight compared to the others. However, ANOVA doesn't tell us which groups are different, just that a difference exists. Step 5. Post hoc test, Tukey's HSD. To find out exactly which groups are significantly different from each other, we use Tukey's honestly significant difference test. As you see, the output shows, for treatment 1 versus the control group, the mean difference is -0.37, with a p-value of 0.39. This is not statistically significant. For treatment 2 versus the control group, the mean difference is 0.49, and the p-value is 0.19. Again, not statistically significant. But for treatment 2 versus treatment 1, the mean difference is 0.86, and this time the p-value is 0.012, which is statistically significant. Step 6. Visualize the results. To help visualize the differences, we create a box plot. This graph shows the spread and center of weight values in each group. From the plot, you can clearly see that treatment 1 has lower plant weights compared to the control group. Final step, interpretation. Here's what we've learned. The ANOVA test showed that there is a significant difference in plant weight among the three groups. The Tukey test revealed that treatment 1 significantly reduced plant weight compared to the control, and that's how you perform a one-way ANOVA in RStudio. We checked assumptions, ran the analysis, interpreted the output, and visualized the results. You can find all the R code used in this video in the description below. Just scroll down, copy it, and try it out with your own data. If you found this helpful, don't forget to like, subscribe, and leave a comment. Thanks for watching, and see you in the next tutorial.